Hey there, science fans. Bill Nye here, and today, we're diving into the fascinating world of magnetic energy. You can't see it, you can't touch it, but trust me, it's all around us. From the compass guiding explorers to the headphones blasting your favorite tunes, magnetic energy plays a crucial role in our lives. It's a force to be reckoned with, and the best part is, you can even create it at home. Think about it. What makes a refrigerator magnet stick? Why does a compass needle always point north? It's all thanks to the magic of magnetism. We're going to unravel these mysteries and explore how this invisible force shapes our world. Get ready for some electrifying experiments and mind-blowing discoveries. So, buckle up, science explorers. We're about to unlock the secrets of magnetic energy and learn how to harness its power. Get ready for a journey filled with wonder, excitement, and maybe even a little bit of magic. Let's go. Now you might be thinking, magnets? Those things I use to stick my drawings on the fridge? Well, yes, but there's so much more to them than meets the eye. Magnets are like tiny powerhouses, constantly emitting an invisible force field. This field is what attracts or repels certain metals like iron, nickel, and cobalt. Think of a magnet like a tiny planet with two poles, a north pole and a south pole. Just like on Earth, opposite poles attract each other, while like poles repel. That's why the north pole of one magnet will stick to the south pole of another. It's all about that magnetic attraction. But here's the really cool part. This magnetic force isn't limited to just magnets. We can actually create our own magnetic fields using electricity. That's right, electricity and magnetism are like two sides of the same coin. They're interconnected in a fascinating dance of energy. Think about the electric motor in your vacuum cleaner or the generator that powers your home. They all rely on the interaction between electricity and magnetism. By passing electricity through a wire, we can create a magnetic field, and by moving a magnet near a wire, we can generate electricity. But the wonders of magnetic energy don't stop there. From high-speed trains levitating on magnetic tracks to MRI machines allowing doctors to see inside the human body, the applications are truly astounding. So, are you ready to delve deeper into the world of magnetic energy? We're about to embark on a journey of discovery, learning how to create our own magnetic fields and explore the incredible possibilities they hold. Trust me, this is one science adventure you won't want to miss. Alright, science sleuths. To really grasp how magnets work, we need to zoom in on the tiniest building blocks of matter atoms. You can think of atoms like mini solar systems. In the center you have the nucleus, which is like our sun, and whizzing around the nucleus are electrons, like tiny planets in constant motion. Now these electrons aren't just randomly zipping around, they're spinning, like tops, and this spinning creates a tiny magnetic field. It's like each electron has its own little bar magnet. Pretty cool, right? But here's the thing. In most materials, the magnetic fields of all the electrons cancel each other out. It's like having a room full of spinning tops, all going in different directions. The net effect is zero. Section 2, magnetic domains, tiny teams with a big impact. However, in certain materials like iron, nickel, and cobalt, something amazing happens. The atoms group together in tiny regions called domains. Think of domains like little squads of electrons, all spinning in the same direction. When these domains align their magnetic fields, the material becomes a magnet. It's like all the spinning tops in the room suddenly start spinning in sync, creating a powerful combined force. Now, when you bring a magnet close to a piece of iron, for example, something interesting happens. The magnetic field of the magnet influences the domains in the iron, causing them to align. This creates a magnetic attraction, and voila! The iron sticks to the magnet. The strength of a magnet depends on how well these domains are aligned. The more aligned they are, the stronger the magnetic field. Section 3. Types of magnets, from fridges to labs. Now that we know how magnets work on the inside, let's talk about the different types we encounter in the world. We've got permanent magnets, the ones we're most familiar with, like those holding up pictures on our fridges. These magnets are made of materials that naturally have aligned domains, so they're always magnetic. Then we have temporary magnets like paper clips. They become magnetized when they're near a permanent magnet, but they lose their magnetism easily when the magnet is removed. It's like the domains get temporarily organized but quickly go back to their random state. And finally we have electromagnets, which are a whole other ballgame. These magnets are created by passing electricity through a coil of wire. The electric current creates a magnetic field, and by changing the strength of the current we can control the strength of the magnet. Electromagnets are used in all sorts of cool applications, from loudspeakers to giant cranes that lift scrap metal. Section 1. Electromagnetism, the dynamic duo. Hold on to your lab coats, science fans, because things are about to get electrifying. We're diving into the world of electromagnetism, where electricity and magnetism join forces to create some seriously cool phenomena. Remember those spinning electrons we talked about? Well, get this, when electrons start flowing through a wire, something amazing happens. They create a magnetic field around the wire. It's like the wire suddenly becomes surrounded by invisible magnetic forces. And the faster those electrons flow, that's what we call electric current, the stronger the magnetic field becomes. This, my friends, is the heart of electromagnetism. Now this isn't just some random scientific quirk. Electromagnetism is the driving force behind countless technologies we use every day. Electric motors, generators, speakers, MRI machines, they all rely on the powerful interplay between electricity and magnetism. Section 2. Building your own electromagnet. A shockingly simple setup. Ready to unleash your inner scientist? Today we're going to build our very own electromagnet using some simple materials you can find around the house or at your local hardware store. Don't worry, it's perfectly safe and a ton of fun. Here's what you'll need. A large iron nail, about 3 to 4 inches long, a long piece of insulated copper wire, about 3 feet, a battery, a D-cell battery works well, and some paper clips or other small metal objects. Now follow these simple steps. 1. Carefully strip about an inch of insulation off each end of the copper wire. We need those bare wire ends to make a connection with the battery. 2. Wrap the wire tightly around the nail, leaving a few inches of wire free at each end. The more turns of wire you make, the stronger your electromagnet will be. 3. Attach one bare end of the wire to the positive terminal of the battery and the other bare end to the negative terminal. Make sure the connections are secure. 4. Hold your electromagnet near the paper clips and watch what happens. Section 3. Cranking up the magnetism factors affecting strength. Congratulations, you've just created your very own electromagnet. Now, let's experiment with ways to make it even stronger. Remember, the strength of an electromagnet depends on a few key factors. Current. The more current flowing through the wire, the stronger the magnetic field. Try using a bigger battery or connecting multiple batteries together to increase the current. Number of turns. The more turns of wire around the nail, the more concentrated the magnetic field becomes. Try wrapping the wire even more tightly, or using a longer piece of wire to increase the number of turns. Type of core. The material inside the coil of wire, called the core, also plays a role. Iron is a great core material because it's easily magnetized. Try experimenting with different core materials like steel or even a wooden dowel. As you experiment, you'll notice that the strength of your electromagnet can vary quite a bit. This is because the magnetic field is directly proportional to both the current and the number of turns of wire. So, if you double the current, you double the magnetic field strength. And if you double the number of turns, you also double the strength. Section 4. Exploring the possibilities. Fun experiments with your electromagnet. Now that you're a master electromagnet builder, let's have some fun. Here are a few experiments you can try. Magnetic treasure hunt. Hide some paper clips or other small metal objects around the house and use your electromagnet to find them. Electromagnetic crane. See how much weight your electromagnet can lift. Try picking up different objects like paper clips, nails, or even small toys. Magnetic compass. Did you know you can use your electromagnet to create a compass? Just hang your electromagnet from a string and let it spin freely. The north pole of the electromagnet will align itself with the Earth's magnetic field, just like a regular compass. As you experiment, think about all the ways electromagnets are used in the real world. From the electric motors that power our cars to the giant magnets used in medical imaging, the possibilities are truly endless. Hold on to your hats, science fans. We're about to embark on a whirlwind tour of the amazing ways magnetic energy powers our world. You might be surprised to learn just how many everyday gadgets and groundbreaking technologies rely on this invisible force. Let's start with something you probably use every day. Headphones. Yes, those tiny speakers that bring your favorite music to life are powered by magnets. Inside each earbud, a tiny electromagnet interacts with a permanent magnet, causing a diaphragm to vibrate and create sound waves. It's a symphony of science and sound. But the magic of magnets doesn't stop there. Think about your computer's hard drive, storing all your precious photos, videos, and documents. It's essentially a spinning disk with billions of tiny magnets, each representing a bit of data. When you save a file, an electromagnet aligns these tiny magnets to store the information, and another electromagnet reads the data when you need to access it. Powering our world, magnetic energy in action. Now let's zoom out and explore how magnetic energy powers our world on a larger scale. Remember those electromagnets we talked about? Well, they're the driving force behind electric motors, which are found in countless devices, from household appliances to electric cars. An electric motor works by using the interaction between a magnetic field and an electric current to generate rotational force. By passing electricity through a coil of wire, our electromagnet, inside a magnetic field, we can create a spinning motion that powers everything from your blender to the wheels of an electric vehicle. But magnetic energy isn't just about making things spin. It also plays a crucial role in generating electricity itself. Power plants use massive generators that rely on the principle of electromagnetic induction to produce the electricity that powers our homes and cities. The future is magnetic innovations on the horizon. As we delve deeper into the 21st century, the future of magnetic energy is brighter than ever. Scientists and engineers are constantly pushing the boundaries of what's possible, exploring new and innovative ways to harness this powerful force. One exciting area of research is maglev transportation. Maglev trains use powerful magnets to levitate slightly above the track, eliminating friction and allowing for incredibly high speeds. Imagine zipping between cities at hundreds of miles per hour, all thanks to the magic of magnetism. But the potential of magnetic energy extends far beyond transportation. Scientists are also exploring its use in medical treatments, such as magnetic resonance imaging, MRI, which uses powerful magnetic fields and radio waves to create detailed images of the inside of the body, helping doctors diagnose and treat a wide range of conditions. And let's not forget about renewable energy. Researchers are developing new types of wind turbines that use magnetic levitation to reduce friction and increase efficiency, harnessing the power of wind to generate clean and sustainable energy. The possibilities are truly limitless. As we continue to unlock the secrets of magnetic energy, who knows what incredible innovations the future holds. One thing's for sure, it's an exciting time to be a science enthusiast. Magnetic safety, respect the force. We've had an absolute blast exploring the wonders of magnetic energy, haven't we? But before we wrap up our electrifying adventure, it's crucial to remember that even invisible forces deserve our respect. While magnets are incredibly useful and fascinating, it's important to handle them with care and follow some basic safety guidelines. First things first, keep those magnets away from electronics. Strong magnets can interfere with sensitive electronic devices like smartphones, computers, and pacemakers. Think of it like this: your gadgets thrive on a delicate balance of electrical currents, and a rogue magnet can disrupt that harmony, potentially causing damage or malfunction. So consider those magnets off limits for your favorite tech toys. Next up, let's talk about those tiny but mighty magnets, the ones you find in earbuds, toys, or even on refrigerator magnets. While they might seem harmless, they pose a serious choking hazard for young children. Just like you wouldn't leave loose buttons or coins lying around, it's crucial to keep these small magnets out of reach of curious little hands and mouths. Remember, safety first, science second. Science. The magnetic frontier, unleashing the potential. As we conclude our journey into the captivating realm of magnetic energy, one thing is abundantly clear. This invisible force will continue to shape our world in extraordinary ways. From the smallest gadgets to the most groundbreaking technologies, magnetic energy is an indispensable part of our lives, and its potential seems as boundless as the universe itself. Imagine a future where maglev trains whisk us across continents at lightning speeds, where magnetically levitated buildings withstand the most powerful earthquakes, and where fusion reactors harness the power of magnetic fields to unlock clean and limitless energy. These might sound like scenes from a science fiction movie, but with the rapid pace of scientific advancement, they could very well become our reality in the not-too-distant future. But the true magic of science lies not just in groundbreaking inventions, but also in the spirit of curiosity and exploration that drives us to unravel the mysteries of the universe. So, keep asking questions, keep experimenting, and never lose your sense of wonder. Who knows what other amazing secrets of magnetic energy are waiting to be discovered? The future of science is in your hands, and it's looking brighter and more magnetic than ever before.